Hi everybody, welcome back to our introduction to responsible AI. Today we're going to be exploring and having a conversation a little bit around the topic of bias. So let's jump right in. Imagine you had a bag of candies, Smarties, red ones, green ones, blue ones, and your favorite are the red ones. And you open the bag and all that you would be picking are the red ones. Now imagine you train a computer system, an AI system, to pick the red Smarties because those are the ones you like. That's a form of bias, and that's a form of bias you've introduced to the machine learning or AI model. It doesn't mean the bias is bad because it's not unfair unless the blue Smarties would feel that they also need to be selected. But in this case, it's for you, it's for your taste, it's the ones you like. So there is bias in the system, it's just not unfair bias. Now let's look at the next scenario. So bias really is sort of this disproportionate weight in favor or against an idea. And we do that every day, we make business decisions. There is bias built into the way we operate and the way we work, else we would never be able to make a decision. But there's also unfair bias. And that's the type of bias we want to manage, mitigate, control, report on, and monitor in AI systems. There needs to be some level of bias because of the outcome that you need to produce, but it must be fair. So let's look at this scenario. There are two people in this picture, a 60-odd-year-old and a 30-odd-year-old. Now, if I had to charge the 60-year-old 500 Rand for some risk cover and the 30-year-old 200 bucks for some risk cover, would that be bias? And would that be unfair bias? Now, we're only taking age into account when making this decision. Now, imagine the next story. The 60-year-old is a really fit, healthy person, and the 30-year-old is a smoker, overweight, and not a very active lifestyle. So do you still feel that the 500 Rand charge for a risk cover for the 60-year-old is fair versus the 200 Rand? Okay, so what you would see is we're introducing more factors that could influence the outcome of the decision. And which is fine because we need to have bias to make decisions on picking prices, products, etc. We just need to make sure that we've got the right influencing factors and weights of those factors included in the system with a proper amount of data to make sure that we don't introduce unfair bias in our decision making. So if we have to sort of look at some of the ways to where bias come from, of course most of this is introduced by us as humans, and the first sort of main source is data bias. So if you are going to use data that's got unfair bias built into it, whether that's because of the sample set of data that you choose, maybe you chose a specific historical data set to teach your model on, and circumstances have changed. You could be excluding certain groups or sets or pieces of information on your data set because you believe it's not relevant. And then also confirmation bias. Sometimes when working with the data, you would pick sets or features of data that supports your bias in confirming your beliefs and how the outcome should look like. So data is a source of bias. Doesn't mean it's unfair. That's what you need to look out for. Algorithmic bias. So the algorithm that uses the training data and makes the predictions and outcomes, there could be bias built into that. Either from a processing perspective, there could be confirmation bias as well in the algorithm because you may want to tweak some of the weights and the hyperparameters of these models. And really you need to be careful not to change those hyperparameters for your own confirmation. And of course selection bias. And then the third major source of bias is interaction bias. We interact with many of these systems, they learn from us, and that could introduce bias. And again, there's the possibility to introduce unfair bias based on human interaction. You could think of the likes on social media. Next time you log into the system, it knows this type of content is what you like, and it will start to sort of surface that. So that's interaction bias. Because it's interacting with us, it's introducing bias because you like this type of news or this type of picture, but it could also introduce unfair bias. Okay, so how do we mitigate for unfair bias in AI? Make sure you've got a diverse data set that's representative of the use case that you intend using it for. Make sure your data pre-processing doesn't exclude certain pieces of information that is vital for fair decision making. Feature selection. In the one example that we looked at, you only look at age. Is that a sufficient feature to make a decision, or is age and health sufficient? What are the important features that's going to help you produce a fair decision? If you've got too many features, that's going to influence your model. If you've got too little features, that's going to influence your model. So feature selection is important, algorithm selection important. If you're going to use a regression algorithm where you should be using a clustering algorithm, of course there's going to be some issues and it could introduce unfair bias. Regular audits is important. Explainability by design. So you need to make sure that the use case you build your system for is explainable in a sufficient manner that is required by a use case and that people can understand. Inclusivity in testing and validation. Make sure you've got an inclusive group of people validating and testing. And the legal considerations. There are some laws in some countries that require certain biases be introduced. And those are legal obligations. So making sure you include your legal requirements in those biases will make sure you don't have an unfair bias. And then if you look at the way we can monitor for unfair AI bias, is clearly you need to have some continuous monitoring. You could get model drift, where over time what you might have learned the model on a set of data, but over time this data changes as it gets new data, and the model might not perform the way it was performing on your training data. Poisoning, which could be introducing data into your model to skew the decision making, to introduce bias, which could be unfair bias as well. Of course, for legal, there might be a new legal requirement in terms of impacting the stakeholders that's going to using your system or the users. So make sure you include the required legal requirements into your model so that you don't get unfair bias. And edge cases as well. Sometimes you need to make sure, because your model generally gets trained, everything looks fine, and then you get some edge cases. So one example is one of these smart home cameras that unlocks the door if it recognizes you. The guy came home, it's been working perfectly fine. This day he came home with a Batman face on his shirt, and the door refused to open because it didn't recognize Batman as somebody that should be allowed into the house. Feedback loops are important, and the processes and methods for getting that feedback and evaluating it. If you are just sending the system out there to be used and you don't have appropriate feedback mechanisms, you're not going to be able to pick up on some biases that your team might not be able to do. And then transparency reporting. Make sure you report how your systems are behaving, making sure that they're being monitored, and be transparent about it, because you can get input to fix, change, adapt, update. You do get bias detection tools, you get AI audit frameworks you could use. Human in the loop is always a good method to make sure there's people in the loop with these decisions to ad hocly check up on these decisions to try to spot unfair bias. And then you could introduce an ethical advisory committee or a board to also continuously look for unfair bias in your models. And then what I would like to leave you today is a bit of food for thought. This is called the trolley problem, so many of you might have heard about it. But think of this scenario. There's a self-driving car. It needs, and it cannot go anywhere else than route A or route B. It needs to make a decision. How would you like this model to make that decision? What are the factors that would influence you to either drive over the lady or to drive over the baby? I'm going to leave that with you today, and I look forward to seeing you in the next session where we will be exploring transparency in a little bit more detail. Hope to see you again. Cheers for now.